Good morning, Algebra 2. Today we are going to be talking about power functions. And power functions are going to be the basis behind everything we do in Chapter 7. So here are your basics. When you have a power function, it's going to appear as such. You're going to have some number down here to some number up here. This x is your base. Your n is what we call your exponent. And the whole thing put together would be your power. So x to the nth is your power. X is your base and n is your exponent. So those are your parts of your power functions here. Example 1. Suppose the probability of answering each question correctly on a 5-question quiz is 3/8 and that the questions are independent. What is the probability of you getting all 5 questions correct? So what we're going to do here is we're going to think about probability, and probability, just remember, is the chance of something happening. So we want all 5 of our questions to be correct. So I'm going to go ahead and make a little slot for all 5 of my questions here. Alrighty, so here's question 1, here's question 2, here's question 3, question 4, and question 5. And that's all we have on this quiz. Now each of these questions has a chance of, if I just guess, that I'm going to get 3/8 of a chance of me getting it correct. So 3/8 of a chance of getting the first question correct. 3/8 of a chance of me getting the second question correct. 3/8 of a chance of me getting the third question correct. 3/8 of a chance of me getting the fourth question correct. And 3/8 of a chance of me getting the 5th question correct. Now, probability, if each of these are happening independently, to find how much the total probability would be to take each event and you would have to actually multiply them all together to find your total probability. So what is happening here is we're taking 3/8 and we're multiplying it by itself 5 times over. And that's exactly what a power does. A power tells you to take the base and multiply it by itself however many times the exponent says. So what we do is we rewrite this and we say here's our base. So 3/8 is that whole thing's our base. I know it looks a little weird because it's a fraction, but that's okay. Now we're taking our base and we're taking that whole thing to, well, we have 1, 2, 3, 4, 5 questions, so to the 5th power. So you take 3/8 to the 5th. Now the nice thing about fractions is that you can take each part separately. So you could do your numerator to the power, so 3 to the 5th power, and then your denominator to the power. So as long as everything gets hit with that 5th power, you're good. So 3 to the 5th and 8 to the 5th. So I don't know what either of those are, so let's go ahead and grab our calculators here. Turn it on and we say, all right, 3 to the 5th, 3 to the 5th equals 243. So let's go ahead and write that down. 243 over, and then we have to figure out what 8 to the 5th is, so 8 to the 5th power. And okay, that's 32,768, so 32,768. Now that as a number really means nothing to us. Typically when we do probabilities, we find them as percentages. So what we do here is we say 243 then divided by, because that's just what a fraction of our means, so divided by 32, well, we could just say second answer here. And then we say, all right, well, that's 0.007. So 0.007. I'm just going to go ahead and throw the 4 in there as well, just so we have a more accurate number. Now that is as a percent, or excuse me, as a decimal. If we wanted to get it as a percent, we know we have to take this decimal and move it over 2 places. So our percentage would then become 0. Notice the decimal point is still before the 7. 0.74%. So now that's as a percent, which, as you can see, that's less than 1% chance of you acing this quiz. So, moral of the story, study for your quiz. Even though it's only 5 questions, studying might help. All right, let's go ahead and talk about simple power functions. We're going to go ahead and go through all the different functions you might see, and then in the next video we're actually going to start graphing some of these. So when you're talking about a power function, all that means is that you're going to have this function here. Now f of x, remember, is just function notation. F of x equals x to the nth power, whatever number this is. And that's why we say nth power function, because we could put anything in here for n that we want to. We could put 1, 2, 3, 4, all the way up to 100 if we wanted. So that's just what a power function is. Your identity function is your simplest one, of course, starting with your power being 1 here. So we have f of x equals x to the first power. Now typically if we have something to the first power, we don't usually write it down. So we just have f of x equals x, which you all know is a linear function. That's why its graph produces here a line. Now this is going to be the plainest linear function that you ever did see. It has a y-intercept of 0, and your slope is going to be up 1 over 1, up 1 over 1, up 1 over 1, which matches our function over here. We have plus 0 for our b, so our y-intercept is b is 0 here. And our slope, if we had anything out in front of this x, it'd be a 1, so that would mean 1 over 1, so up 1 over 1. So that's your identity function, the plainest linear function ever. Your squaring function is what comes next, and that is, as you may recognize, your quadratic function, or the second power function. That's why we have an exponent here of 2. So f of x equals x squared. Now, we just studied these very in depth, so you know that that's going to make yourself a parabola. Notice your vertex here is going through the point 0, 0, and it's just a regular old parabola. So that is your squaring function. So now we used to call them quadratic functions. Now we're going to be calling them squaring functions. All right, they are one and the same. The next type of function we have yet to study, that is the next power up, so f of x to the third power. So that would be your cubing function, or we could call it the cubic function. It's your third power function, and it looks something like this. It now has, it looks like part of a parabola here, and then the other part would go up this way, but it looks like the back half of this parabola has been flipped downward. So now your cubic function kind of makes like an S curve. So again, just like the first two were your basic linear and quadratic functions, this is your basic cubic function, going through the point 0, 0, and just taking its normal course here. Now anything above that, we're not actually going to cover in too much of depth, because any nth power function where n is greater than 3, like 4, 5, and 6, they don't have any special names. We just say it's the 5th power, the 6th power, the 7th power functions, and so on and so forth. Please continue in the next video for our examples of graphing these.